So next we will deal with some questions. Suppose you have a question, function of ABC equal to sigma m, say 0, 1, 5, 6. Okay. Now I want you to simplify this . Simplify the canonical form using Kmap and hence draw the truth table and circuit using NAND only. Suppose this is the question. So function of ABC equal to sigma m 0, 1, 5, 6. So we have to first, I just drop the question. So my Kmap is A, B, C. A can take two values 0, 1, 0, 0, 0, 1, 1, 1, 1, 0. This is 0, 1, 3, 2, 4, 5, 7, 6. Next we'll write the ones. So 0 will have a 1, 1 will have a 1, the cell 5 will have a 1 and 6 will have a 1. Now how do you group this? These two ones you can group like this. This one should be grouped, so we will go for two ones in a group. This one I cannot group with any of the other ones, so I can group it only single. So the answer will be, for this particular group, it will be A is not common, only B and C is common for those two ones. So that is B bar C plus this group A bar B bar plus this one A B C bar. Yes. So we'll then draw the truth table. So A, B, C, this is your output. So ABC 0, 0, 0, 0 to 1, 1, 1, 0 to 7. It can take values from 0 to 7. 0, 1, 2, 3, 4, 5, 6, 7. So wherever you have put 1, that is, if the output is 1 if the input is 0, 1, 5 and 6. Okay, if any of these comes, output is 1. So 0 means 0, 0, 0. So 0, 0, 0, it's 1. Then 1. For 1 also it's 1. Then 5. This is 5. And this is 6. So for these, the output is 1. And for others, we have not marked anything. So that means for others, the output is 0. So this is how you draw the truth table. So this is the actual meaning of this or the total Boolean expression. So if you take a particular example, suppose if 0, 0, 0 is taken and you are applying it to this particular equation. 0, 0, 0 means A is 0. So first term is B bar C. B bar C means B is 0 and C is 0. So B bar C will be, B bar will be 1, C is 0. So 0 plus A bar B bar. So 0 bar 0 bar, that is 1, plus ABC bar 0 0 1, 0 0 1. So that will be, this is 0, this is 0, this is 1. So you got the answer 1. Likewise, suppose I am taking a 0, 0 1 0. I am taking 2. So 0 1 0 means B bar C. B bar C, B bar 0 dot 0, A bar B bar, A bar 1 0, 1 dot 0 plus ABC bar, A B C bar. So 0 1 1. So that will be, this will go, this will go, this will go. Everything is 0. So likewise you can check any of these. If you check any of these, you will get the corresponding value. So from this canonical form you can write the Kmap, you can write the simplified expression, you can write the min terms if required, you can write the truth table if required, and from the final expression you can draw the circuit also. So in order to draw the circuit, so A, you have an A bar. So the question was draw using NAND only. So for bar you need to put a NOT gate. So this is your A bar. B bar, C, you have a C bar, so you need another NAND gate for C bar. So you should draw only like this. Don't use ABC multiple number of times in the circuit. Draw it only like this. Now after this, B bar C, so that is an AND gate. So SOP using NAND. So SOP using NAND means you will connect these two NAND B bar C. This is B bar C the whole bar. A bar B bar, A bar B bar, A bar B bar the whole bar, A B C bar, A B C bar, A B C bar the whole bar. Now you will connect this to another NAND gate to get the final output, which is F in this case. So this will be okay. So F is this into this into this the whole bar. So you will get this as the answer. So this is your final expression. Right? Suppose you have a Kmap for which function of AB equal to sigma m 0, 1, 2, 3, or function of ABC equal to sigma m 0, 1, 2, 3, 4, 5, 6, 7, or function of ABCD equal to sigma m 0, 1, 2, etc. 14, 15. That is all the numbers from 0 to 15. So in all these three cases, we know that all the cells in that particular Kmap is filled. In the first case, it's a two variable Kmap. In that, all the 4 cells are 1. Here, all the 8 cells are 1. Here, all the 16 cells are 1. So if I take the first case, for example, AB 0, 1, 0, 1. So this is my Kmap. So everything is 1. So this means that if the input is 0, 0, the output is 1, 0, 1, the output is 1, 0, 1, 0, the output is 1, and 1, 1, the output is 1. So what does that mean? The output is 1 whichever be the input. Similarly, in this case also, if you draw the 3 variable Kmap, all the cells are equal to 1. You can group it as a single octet. So in this case also, output is 1 whatever the input. So here also the output is equal to 1. Similarly, in this case also the output is equal to 1. So if you have all the cells equal to 1 in a particular Kmap, then that means that the output is 1 irrespective of the input. Now if you take POS, product of sum, in the case of POS, how you write is function of AB, if it's a two variable, equal to pi capital M, then in bracket say 0, 1, 2, something like this. So again you draw the Kmap. The way you draw the Kmap is the same. A, B, 0, 1, 0, 1, 0, 1, 2, 3. Now what do you mark? So this means that this is product of max terms. M denotes max term. Now what is a max term? In the case of min term, it was product. Max term is sum. Okay. And whatever numbers, cell numbers you are giving, those cell numbers you will be putting a 0. Okay. Then grouping. So here you will be grouping the zeros. Similar to SOP, where in SOP you will be grouping the ones, in POS you will be grouping the zeros. So after grouping, how do you read it? So here we are grouping the zeros. There you were grouping the ones. So how you will write is, suppose you are grouping this particular group. Here what is common? B is common. And what is B? B is 0. In the case of SOP, when you are grouping ones, you'll write if a literal is 0, you'll put it as complement. If a literal is 1, you'll keep it as the same literal itself. Here it's just the opposite. So here if the literal is 0, then you will keep it as the same literal. And this is for one group. When you go to the next group, you'll put a AND symbol. In the other case, you were putting a plus sign or symbol. So next group is A is 0. A is 0 means A. So it is AB. Similarly, suppose it is 0, 1. So 0, 1 means so 0, 1. You'll group it like this. So it is A, not A bar. Suppose next question is ABC equal to 0, 1, something like this. So 3 variable, zero, 1, 3, 2, 4, 5, 7, 6. So 0, 1, 2, 4, 6. So these 4 ones we can group it by folding. This one you can group like this. Sorry, these are all zeros. It is POS, so you'll be marking it as zeros. So this 4 zeros, how will you take? No, A is not common, only C is common. C is common, and what is C? C is 0, so you'll write it as C into this particular group. For these 2 zeros, it is A is 0. A is 0 means A plus what is common in B? B is 0. So it is C into A plus B. Suppose you have 4, 5, 6. A, B, C, 0, 1, 0, 0, 0, 1, 1, 1, 1, 0, 0, 1, 3, 2, 4, 5, 7, 6. So 0, 1, 2, 4, 5, 6. So here you can group these 4 zeros together, and these 2 zeros you can group it as a quad. So how will you write? These 4 zeros, common value is C equal to 0, so that is C into this 4 is B equal to 0, so that is BC. Is your CB. So that is POS. Now next is don't care. So in this particular case, see, in SOP we are writing ones, that is you know when the output is 1. In POS you are writing 0, that is in POS you know when the output is 0. Now don't care is a situation where you don't know what the output is. Output is unknown. So don't care is represented by an X sign, and the question will come as, suppose function of ABC equal to sigma m 0, 1, 2 plus D 4, 5, 6, something like this. Okay, so here what you should know is sigma m notates that this is an SOP, and if it's an SOP then here the plus sign should come, and this D should be small letter, and that indicates the don't care. So in SOP, if it is sigma m and not pi m, if it is SOP, here you should have plus and small d. Okay, so how will you draw this? A, B, C, 0, 1, 0, 0, 0, 1, 1, 1, 1, 0, 0, 1, 3, 2, 4, 5, 7, 6. So 0, 1, 2, 0, 1, 2, this is SOP, so we are putting 1, and D 4, 5, 6, 4, 5, 6 will put the don't care sign. Now the rule is a don't care can be used, can be grouped with a 1 in SOP, and if it is grouped with a 1, then that means that the don't care is treated as a 1. And when do you group the don't care with the 1? In order to make the group bigger. That is, the number of ones in the group can be made more by using a don't care, 1 or more don't cares. Then you can use those don't cares. So in this particular case, normally if you don't have the don't cares, you will be grouping it as these 2 ones and these 2 ones. In this particular case, these 2 ones, instead of grouping it as 2 ones in a group, you can group it as 4 in a group by using these 2 don't cares also. So more the number of elements in a group, more simplified the expression. And these 2 can be grouped with these. So 4 in a group. So it is more simplified. So this will be B bar plus Okay, so if we didn't have the don't care, if we didn't use the don't care, then you'll be grouping it as these two ones. So that will be A bar, B bar plus A bar, C bar. Here we needed more gates, here we need less gates. So when you have don't cares, you can group it with the ones in order to make the expression simpler by making the number of elements in a particular group larger. So this is wrong and this is the correct answer. Okay, you cannot write like this, you can write only like this if this is the question. But don't use don't care unnecessarily. Don't group don't cares without any requirement. For example, suppose we had this is 0 1 0 0 0 1 1 1 1 0. So suppose this is the question. Okay, function of ABC equal to 0 1 2 3 4 plus D 4 5. This is the question. Then what you'll do, these four ones you can group it like this. Okay, here these four ones are grouped together. Now you cannot make this a bigger group. Okay, after 4 the next bigger group is 8. So here we can't make it to a group of 8 because here these two are vacant. Here these two cells are 0. So this is the only possible way. So don't go to group these two don't cares. Here we don't need these two don't cares. So all don't cares needn't be grouped. Don't cares, there is no rule that don't cares needn't be grouped always. Group it only if necessary. Okay. Just because these two don't cares are there, don't make another group like this. That will only increase the number of terms, thereby increasing the number of gates. So this is the answer, and the answer is A bar. Okay, do not use this don't care. Suppose it is like this. It is 1 here and don't cares here. In this case, instead of grouping the single one, you can group it as 4 in a group and you can write as 1. Here you need these 3 don't cares in order to simplify the expression. Okay, so wherever necessary you should use the don't cares. If not necessary, don't use the don't care. Suppose here my question was this. So in this case you can group this one with this don't care and write it as suppose A bar, or you can group this one with this don't care and write it as B bar. But don't group this one twice because this don't care can be left as such. This don't care, there is no rule that all the don't care should be grouped. There is no such rule. So this don't care is left, we are using only this don't care, because 2 in a group is the best possible way to group this particular question. So this one can be grouped either with this don't care or with this don't care, not with both of them. Okay, it is just one term. It is either A bar or B bar. It is not A bar plus B bar. Okay, so that is what don't care is. Now similarly, in the case of POS also, POS rules remain the same. All the rules are the same. You just write it like a normal POS. Suppose this is 0 and this is don't care and this is don't care. You group it like this and write it as A. Okay. Suppose you have a 0 here. Then how will you do? Then you can group it like this and again group it like this. And you can write as A into B bar. Okay. So in this case, all the zeros should be grouped. And a don't care can be used any number of times. So here we need 2 groups. And if suppose I have a 0 here also, then we'll group it as a single group, not 2 or 3 groups, single group. And what will you write? So here we are grouping zeros. So when you are grouping zeros, what does this mean? Whatever be the input, the output is always 0. So my answer is 0. So in SOP, if all the cells are equal to 1, then the output is 1. In POS, if all the cells are equal to 0 or don't care, then output is 0. So that is SOP, POS and don't care. So solving using Kmap. Now suppose I had a question. In POS, the don't care is given as dot D. In the SOP, it was plus D. In the POS, it is dot D. See, the numbers here and here should not be the same. It will not be the same. You can't have a don't care and a 0 in the same cell. You can't have a don't care and a 1 in the same cell. Okay. So this is POS. Pi m will show it's a POS and here it is dot D. So A, B, C, 0, 1, 1, 1, 1, 0, A, B, C, 0, 1, 0, 1, 4, 2, 3, 5. So here we will, in this particular case, these 2 zeros should be grouped with this. This is the only possible way to group. Don't group it with this. Why? Because this contains the maximum number of zeros. You have 2 ways, but then if you group it like this, then again for this particular 0 you have to go for another group. In this particular case, you can go with just a single group. Lesser the number of groups, lesser the number of gates. So here if we write like this, it is just B. Okay. Now suppose my question was something like this. Okay. If this was my question, then how will I group? These two zeros I'll group like this. This 0 I'll group with this, don't care. And how will I write? It is A plus B into A bar plus C bar. Okay. And how will I draw this? In order to draw this, you have to go for NOR only. So in order to use NOR only, A bar, B, you don't have a B bar, you have C bar, so that is C bar. So A plus B will be A plus B, that is a NOR. So that is A plus B the whole bar into A bar plus C bar. A bar plus C bar. This is A bar plus C bar the whole bar. So give this to another NOR. So this will be A plus B bar plus A bar plus C bar the whole bar. So this will be A plus B double bar into A bar plus C bar double bar. So that is A plus B into A bar plus C bar. Which is what we need. So this is PO